All right, so this lesson for trig is found in 4.2 and for pre-calc is in 3.2. This is the math behind the logarithmic functions. If you haven't watched our previous videos, we already did the graphing for log functions. So the first thing we're going to do is convert between exponential and log, okay? The best way I can help you memorize this is to drop the base and change the x and the y. So the exponential function is the one with an exponent, and the log function is the one with a log. So if you want to convert from one to the other, whatever number is in the place of the base stays as the base. One is the base of an exponent, the other one is the base of the log. And then whatever is in the spot of x and y, whether it be a number or a variable, you just change their locations. Okay? We're going to see some examples of those in a minute. Now, back before we had our fancy calculators, change of base was actually a really important formula. Okay? If I had log base 14 of 7, my calculator wouldn't do that on its own. I would have to use the change of base formula to then say log of this top number. So let's say log of 7 divided by log of 14, and then my calculator would do that. Okay? So looking at your calculators, next to number 7, we have the log button. Okay? So I'm just going to show you really quick. Right here next to 7, we have our log button. Now, I don't know if you remember from Algebra 2, log without a little base is a base of 10, which is what that button does. That button only does base 10, which is why we need this change of base formula whenever we have a different base. Okay? Now, our beautiful new calculators exist, and they have a button that lets you put in a different base. Okay? So you have two options. Math A should work for all of you. If you have the new TI-84, which most of you have, Alpha Window 5 also gives you that button. So go ahead and press either of those. And you should see something that pops up like this. Okay? So if we're looking at my calculator, you see the difference between when I press the log next to the number 7. It just puts log without a base. That assumes that you are in a log base 10. If I have a different base, Math A, okay, puts the two little boxes, and now I can do that log base 14 of 7. Now that's allowed, okay? So again, change of base won't be super mandatory for us in this chapter, and not even for your SATs and ACTs, because you are allowed to take this calculator in, okay? Does that make sense? All right. Let's move on to some examples. So on slide 5, if you're following along with my PowerPoint, and 6, we talk about converting, okay? So I want you to convert back and forth and solve for x. Now make yourself a little mental side note. You are allowed to solve for x before or after you convert, depending on where you think it's easier to solve for x. Okay, so don't feel like you have to convert and then solve for x. So I'm going to do A on both of these with you, and then I'm going to give you a moment to do B on your own. So let's look at A here. It's in the form of log, and I want you to convert to exponential and solve for x. The first thing I'm going to do is rewrite it so my log is first, so it looks like my notes. And I could say log base 2 of x equals 4. Now when I want to convert, I drop the base, so I put 2. And then I switch the location of these two. So I put the 4 and I put equals x. This right here is the answer of your conversion. Do you feel like it is easier to solve for x in exponential form or in log form for this question? Exponential. What is 2 to the 4th power? Good. So I could say x equals 16, and I have 2 answers for this question. Okay? Let's look at this going in the other direction. Something raised to 4 equals 6. If I want to convert, I'm going to convert it to log. So I need to put the word log. I'm going to drop the base and switch the location of the 16 and the 4. This is the answer to my conversion. Do you feel that it is easier to solve for B in exponential form or in log form? without your calculator, do you know how to do that log off the top of your head? No. Can you kind of figure out blank raised to 4 equals 16? What do you think B is? 2. 2 to the 4th power equals 16. All right, take a minute, pause, and try B on your own. All right, so for letter B, for converting to exponential, I'm going to rewrite it so that my log is first. You don't have to do this step. Okay. And now I'm going to drop the base and change the spot of the x and the 9. This is the answer of my conversion. And now 3 raised to what equals 9? Nice. 2 answers. Okay. And now B for converting to log. I'm going to write the word log, drop the base, and change the place of the x and the 2. How do you think it's easier to solve, an exponential or in log? Exponential, what is 5 squared? 25. Very good, guys. Okay. All right, so now moving on, we're going to evaluate. Evaluate, guys, again, back in the day we had to do change of base, but because we have these fancy calculators, take a moment and plug these 3 in and make sure you are comfortable with those buttons. All right, so hopefully when you plug those into your calculators, it looks something like this. Okay, put the base and the full number. If you do not have one of these fancy calculators, for example, for the first one, you would have put the division of log of 81 divided by log of 8, and you can see that that gives you the same answer. That's your change of base down there, okay? So let's take a moment and fill these in. So let's look at these next set of notes, basic log properties, okay? So these are some common rules that take place. If you have your calculator, you can always check them. Whenever a log has the base and the main number the same, the answer is 1, okay? You could even think of the change of base rule. Like if these were both 5s, you'd have log of 5 divided by log of 5, okay? Now, whenever that happens and you have an exponent to that main number, because these clear out to 1, what you are left with is just that number as your answer. Okay? The same goes for this one. Whenever both bases, the base of the log and the base of the exponent are the same number, your answer is just that leftover exponent. Okay? Here, log of any base of 1 is always equal to 0. And then these two are technically the same as this question right here. Because a log without a base, we said, always has an understood base of 10. So technically my bases are the same. My answer is just 1. And then here, ln's always have an understood base of e. So those two numbers are the same. Therefore my answer is 1. All right. Let's check these out. Log base 8 of 8. What is my answer? 1. Very good. Let's go downward. Log base 7 of 7 squared. What is my answer? 2. Very nice. It's just what's left over. 3 raised to log base 3 of 15. 15. Log base 9 of 9. ln of e to the 2nd power. 2. Very nice. Next, log base 6 of 1, 0. All right, so the next one, 5 raised to log base 5 of 8. My answer is 8. Log base 2 of 2 cubed. I'm going to skip this one for a moment. E raised to ln of 5. 5. Nice. And who has this answer? Who else got -1? It is -1, and here's why. 1 over 3 is the same thing as saying 3 to the -1st power. Remember that? how I can bring that up with a negative exponent. So now my bases are the same. So my answer is just -1. Good job. All right. This now comes from the next section. So in trig, it's 4.3. And in pre-calc, it is 3.3. It is expanding and condensing logarithms. These three rules work identical for log as they do for natural log. Again, remember, natural log is just a specific logarithm, okay? So if you read this chart from left to right, it is expanding. If you read it from right to left, it is condensing. So the first rule says that a single logarithm of two things being multiplied can be split into two separate logarithms, assuming you keep the same base and you add them, okay? The same thing goes for division. If I have a single logarithm of two things being divided, I keep the same base, and now I can write it as two separate logarithms being subtracted. And lastly, exponents on logarithms and natural logarithms are allowed to be interchanged and moved to the front as a coefficient. And same vice versa. If I have a coefficient here, I can move it and put it as an exponent to that n. M and n can be changed by numbers or variables, okay? Now, if I'm condensing and I'm going from the right side to the left, especially for these first two, these two bases have to be the same in order for me to combine them, okay? So you can take these one step at a time, which is what I'm going to do for the first two. But then I want you to understand the concept that when things are separated by multiplication, they will be split up with addition. And whoever has an exponent, just put it at the front as a coefficient. Okay? Whenever you see anything in the denominator, it will have a minus sign in front of it. And then if it has an exponent, you just put it in front of that one as a coefficient. Okay? So let's start off taking it slow. Okay? These two are separated by multiplication. So I'm going to use my first rule and say log base 4 of 3 plus log base 4 of x squared. So all I use right now is that first rule. I can go a step further and use the third rule to move this exponent of a 2 to the front. It only belongs to the x squared, not the 3, so it only goes in front of the log that has the x, okay? So it would be log base 4 of 3 plus 2 log base 4 of x. And at that point, I would be done expanding. Okay? So if I want to try taking the next one all in one step, the x and the y cubed are both in the numerator, so these will both have positives, okay? Numerators have a positive, denominators have a minus, okay? But since they're separated by multiplication, they'll each be their own and have a positive, okay? If you want to go a step further and really do everything at once, I can even go ahead and put that 3 in front of the logarithm that I used to put in front of the y. Okay, so I'm going to do this one in 2 steps. I'm going to say log base 7 of x, y cubed is also in the numerator, plus log base 7 of y cubed, and then z is in the denominator, so this one gets a minus. Minus log base 7 of z. Okay? And again, if you wanted to, if you could have put that 3 up front already and done it all in one step. But this becomes log base 7 of x plus 3 log base 7 of y minus log base 7 of z. All right, for these next 3 questions, we're going to take them all at one step, okay? So E is in the numerator, so E is going to be positive. So I'm going to say ln of e, and instead of writing the cubed on top of the e, I'm going to write it using this rule already as a coefficient. 7 is in the denominator, so I'm going to put minus ln of 7. Now this is an answer of an expansion, but do any of you see something that can get cleaned up there? Talk to me. ln of e does equal 1. So another option you could write is 3 times 1, which is just 3 minus ln of 7. Okay? I would accept either of those. All right, for this next one, I'm going to take a moment and change that radical into an exponent. What would that radical look like if it was an exponent? Right, x plus 3 raised to the half over y times z squared. Okay? Now, be careful. A big confusion that happens is that people see this plus and they want to split it. Remember, it'd have to be separated by multiplication in order to split it. I will not be able to split the x and the 3 because they're separated by addition, okay? So, if it's in my numerator, it's positive. The first thing in my numerator is that x plus 3. And instead of writing the 1/2 as an exponent, I'm going to write it as a coefficient. Now I have 2 things in the denominator, so both of those things will get a minus. I will say minus log of y and minus log of z. Instead of writing the squared here, I'm going to use this rule to already write the squared as a coefficient. Okay. Again, guys, if you feel like doing it all in one shot is too much, take one rule at a time. Okay. All right. Let's take a moment and try and do that last one on your own. That last one reads ln of 100 times x cubed times cube root of 5 minus x divided by 3 times x plus 7 squared. All right, so I am a fan of color coding. So in my numerator, I have the 100, I have the x cubed, and I have the cube root of 5 minus x. I have 3 things that are going to come out with a positive log. In my denominator, I have the 3, and then I have the x plus 7 squared. So I'm going to have 2 things that come out with a minus. Okay? I also have this cubed that's going to go in the front as an exponent. This cube root is like saying 1/3. That's going to go in the front as an exponent. And I also have the squared that's going to go in the front as an exponent. So, one at a time. First, a positive ln of 100. Now, plus ln of x, and then the cubed goes in the front. Okay, now the third one, plus an ln of 5 minus x, and instead of saying to the 1/3, I'm going to put the 1/3 up front. And now we're down to the denominator, so I'm going to start writing with minuses. Minus ln of 3, and then minus ln of x plus 7, but instead of writing the squared up here, I'm going to put it as a coefficient of 2. Again, if you do not feel comfortable doing this all at once, take your time. And there you go. That's 3.3.